Well, welcome back, everybody. We are going to do the second half of Chapter 7, Section 4. Now we're going to solve logarithmic inequalities. Basically the same idea, except inequalities, you've got to deal with some more solutions, so we've got to be a little bit more careful in our thinking. Alrighty, let's start with this idea. Remember, our base is 8. And one of the quick ways to think about it animated is sort of the 8 over there. So 4x is greater than 8 to the first power. Well, 8 to the first power is 8. Divide both sides by 4. We get x is greater than 2. All right, just a quick idea. We should check to make sure we're okay. All right, I told you before, be careful. We don't want this to be a negative value. So 4x can't be negative. But if you think about it, if x is greater than 2, this will always be positive. So we're okay. The answer, x is greater than 2, is correct. All right, let's move on. Equation of logs on both sides, but those logs have the same bases, so we're good. We just said x plus 2 is less than 3x, and we solve this equation like we normally would solve an equation. And divide by 2. All right, so let's look at this answer. X is greater than 1. Right? If 1 is less than x, means we flip it around. If I put x first, x is greater than 1. So look at these two, x plus 2 and 3x. They can't be negative. But as x is always greater than 1, these aren't going to be negative. They're always going to be positive. So we've got ourselves a good answer right there. X is greater than 1. All right, let's look at this one. Log base 11, x plus 7 is less than 1. So we write it this way, x plus 7 is less than, bring the base over here, 11 to the first power. Subtract 7 from both sides. We have x is less than 4. Now, is that our answer? Well, x is less than 4, which means it could be anything less than 4, including negative numbers. So let's just check x plus 7. What I want to know specifically, what values of x plus 7 will give me an answer that's greater than 0? Remember, we cannot take the log of 0 or of a negative number. Well, I subtract 7 from both sides. I have two pieces of information. I know that 1, x has to be bigger than negative 7. And 2, I know x has to be less than 4. So if I think about that, what I'm realizing is x has to be right between negative 7 and 4. Now I use the term right between. I don't mean to imply that it has to be in the middle. Anywhere between negative 7 and 4. 3.99999 works. The same way that 0 works, that 8 doesn't work, that 2 works, that negative 6 works. So our answer has to be both greater than 7 and less than 4, and that's how we write the answer. Okay? All right, what do we got here? X is less than or equal to, we're going to bump that 81 over, 81 to the 0.75. Now, if you have a calculator, you can figure that out pretty easily. However, I don't have, well, I do. I don't want to use it. I'm going to change 0.75 to be 3/4. Okay? The 0 looked weird, so I got rid of it. Remember, the bottom number is the root. What's the 4th root of 81? Well, remember, it's 3, because 3 times 3 times 3 times 3 is 81. So x is less than or equal to 3 cubed. So x is less than or equal to 27. All right, seems good. X is always less than 27. Less than, they're tough. If it's greater than, we don't usually have to worry about 0, but less than is tough. So let's look back here. I know x is all by itself. I know that x must be greater than 0. It must be. You cannot have log base 81 of 0. There's no power that will give you an answer of 0. There's no power that will give you an answer of a negative number. So there's nothing to calculate. I just know this is true. I know x has to be greater than 0. I know x has to be less than or equal to 27. So my answer is all the numbers that are between 0 and 27. But remember, this is less than or equal to originally, which means that it can equal 27, but it cannot equal 0. This is our answer. Every number between 0 and 27. Okay. How's that feeling? Okay. All right, my log base 2. Oh, log base 2. That's great. There's log base 2 on both sides. That actually makes our life much easier, because all we have to do now is compare the expressions. X plus 6 is less than 17. X is less than 11. All right, good. Less than again. If x is less than 11, we're talking about all the numbers that are 0 and negative and all stuff like that go in that direction. So we need to look at x plus 6 specifically. Now what I want to know, I need x plus 6 to be greater than 0, or else it won't work. If x is negative 14, it's going to have a log of a negative, and I can't do that. X has to be greater than negative 6. There's my two stipulations. X has to be greater than negative 6, but x also has to be less than 11. So that means that our answer is going to be between 6 and 11. Now, I always write it like this. I always write it like a number line format. The lowest number first, the highest number at the end, and x is between. Notice how I changed the sign, kind of. Does this not say x is less than 11 right here? Yes. But are these two agreeing? And they are, because remember the mouth is pointing towards x. X is bigger than negative 6. It says negative 6 is less than x. They mean the same thing. Okay. Same thing here. We got the same bases. So we are good. All we have to do is set the expressions 2x minus 1 greater than 5x minus 16, and we go ahead and solve. Subtract 2x from both sides. What's that? 3x minus 16. Whoa, 16. Add 16 to both sides. 15 is greater than 3x. So we'll bring that over here. Divide by 3. 5 is greater than x, which means that x is less than 5. Uh-oh. Okay, x is less than 5. The problem again, if x is less than 5, it can be all the negatives. And we don't want negatives here. So let's look at both of these ideas. 2x minus 1. If 2x minus 1 has to be greater than 0, let me just solve this. Going to add 1 to both sides. Divide by 2. I know x has to be greater than 1/2 to make this side work. Okay? Fix that. Don't like the way that looks. All right, but now let's look at this one. 5x minus 16. What I know, let me put that down here, is I know that 5x minus 16 also has to be bigger than 0. It must be. You can't take the log of a 0 or a negative number. So add 16 to both sides. Whoa, that's not 0. That's 16. Divide by 5. And what I get is x is greater than 16/5, which is a little bit more than 3. Okay, so about 3.2. So look at the three pieces of information I have to put together. X is bigger than 1/2. X is less than 5. But X also has to be bigger than 16/5. All three of these things must be true. So since I know this is a little bit more than 3, isn't this higher than this? So x being greater than 1/2, that's good. But I know this supersedes it. X has to be bigger than 16/5. That's a little bit more important in this case because 16/5 is higher than 1/2. So x has to be between these numbers, 16/5 and 5. We're already good. The logs are the same. So x minus 5 has to be greater than 2x. We subtract x from both sides. All right, I know x is less than -5. And it looks good, except x is less than -5. So we got to double check. All right. I know that x minus 5 must be greater than 0. Add 5 to both sides. Oh, we have a contradiction here. I know x has to be greater than 5. But when I solve the equation, I get the answer that x has to be less than -5. Can x be greater than 5 and less than -5? This is not a range. It can't be both. I mean, it can't be either. Both have to be true. So this is impossible. If x is less than -5, this number, and consequently this number, 2 times whatever the number, will always be 0. This one actually has no solution. It's impossible to solve. Okay. All right, last one. Oh, the logs are the same. That's nice. Let's see what we got here. Let me add x to both sides. X plus x is 2x. Let me add 1 to both sides. Let me divide by 2. So that means over here I've got 2 is less than or equal to x, which means x has to be greater than or equal to 2. Okay. If I plug in 2, am I good? I think we're okay. Let me just double check just to be on the safe side. I know that 3 minus x has to be greater than 0. So if I add x to both sides, I know 3 has to be greater than x, or x has to be less than 3. What about this one? Okay, let's figure out this one. X minus 1 has to be greater than 0. Let me add 1 to both sides. Okay, let's look at our 3 answers here. Our 3 answers are these. X has to be less than 3. X has to be greater than 1. And x has to be greater than or equal to 2. So where are all 3 of these things going to be true? All right, x is less than 3. X is greater than 2. So really, our answer would be 2 and 3. Why is 1 not a part of this answer? Well, if something is greater than 1, but it also has to be greater than 2, then anything between 1 and 2 wouldn't work. Like 1.5. Does 1.5 answer all these questions correctly? Is 1.5 less than 3? Yes. Is 1.5 greater than or equal to 2? No. Is 1.5 greater than 1? Yes. There's 2 yeses and a no, but you know what? They all have to be yeses. So let's take a number like 2.5. Is 2.5 less than 3? Yeah. Is 2.5 greater than 1? Yeah. Is 2.5 greater than 2? Yeah. So if you think about it, all the numbers that are between 2 and 3 are the numbers that will work. Now, because this is less than or equal to, I have the equal to stays with the 2. But it cannot equal 3. Because if it equaled 3, this would be 0, and you can't take a log of 0. So that's why we have a less than or equal to and a regular less than. All right, that's solving logarithmic inequalities. So after this, we're going to have a review, and we're going to have our next test, actually. We're halfway through Chapter 7. So we really only have 6, 7, 9 more sections to go before the year is over. You guys have been doing a great job. Keep it up, and I'll talk to you soon.